learning series, as much information we can bring to you and resources to our members we want to do. Today we are joined by our friends at OpenCounter, who are going to give us a really technology and data focused presentation. So for those of us who spend more time on the qualitative side of things, it's nice to get into this quantitative piece. We have joining us Matt Glister. He's OpenCounter's in-house zoning expert. He's been a planner for over 5 years. He's AICP certified and has worked in a variety of jurisdictions, small communities, large counties, and really focused on implementing OpenCounter and delivering it to kind of clients of all sizes. David is joining us. He's their senior developer. He's been in software development for over 10 years, working on interconnected data model problems across multiple domains. And in the past, he's hacked robot kitty litter boxes to do his bidding, trained a bot using the combined works of Roald Dahl, and created fluid animated maps of crime moving through the city. So kind of to sit on the edge of your seats there. And then Joel, I've known since early 2014. He's OpenCounter's CEO and founder. Also somewhat good at karaoke. And before joining OpenCounter, he founded several startups, including an online travel site, a genetics visualization tool, and an mHealth platform for diabetes. He was an inaugural fellow at Code for America, and his work has been featured in the Washington Post, the Boston Globe, and the New York Times. So thanks guys for being here today and taking the time out of your schedules to bring this information to planners throughout Colorado. This webinar is CM certified, so you'll see at the end and at the beginning the CM credits, but you can always go on our planning.org and register for those CM credits. Don't forget to get those logged. And we'll be taking questions at the end. Feel free to drop them in the Q&A box as we're going, but we'll stop at the end and leave some time there. So I'll hand it over to Joel to get us started and tell us a little bit more about where we are today. Thanks, guys.
Thanks, Michelle. Hi, everyone. I'm Joel. Can you hear me? Is my audio on? Okay, great. Thanks for joining, everyone. We kind of went through the list of attendees before the call. Nice to hear a little bit about where people are coming from, and thanks for taking an hour out of your day to join us. Matt, do I have the controls?
Yeah, I just sent your remote control. Yeah, there you go, Joel. Should work.
Okay. Sorry, just one second. Okay, so OpenCounter was started in 2013. We set out to build permitting and licensing software to streamline the interactions between local governments and its constituents. In a nutshell, you could say we're trying to build a TurboTax kind of experience for permitting and licensing. Since then, we've worked with cities of all sizes across the country. You'll see metro areas on this map: San Diego, Atlanta, Fort Worth, but also a number of smaller communities. And it's very interesting to see how the problems are, the same and different across these communities, and what the common themes are, and how we as a software company can help. Today, what we want to talk about is, I think one of our learnings from working with so many cities is that certainly our software is valuable. I mean, we feel passionate about what we're doing, but I also think the mode of thinking that we bring to these engagements is very interesting for cities, and it's kind of comes out of our collective background as a software company, computer scientists, but we've come into this space. I mean, your space in a way, this the space of planning and municipal code and local regulation. And we've kind of brought this lens of, computer science to help us think about the problems. So just to frame up the conversation for Matt and David today, I wanted to start with this image. This is the municipal code of Los Angeles, six pretty dense looking volumes of code. And we talk internally about how it's interesting that we call this code, right? I mean, it is a kind of code. It's a code base. It's not computer code. It's not kind of interactive yet, but it is a rule set not unlike a computer operating system. And we think a lot about how, our work is really turning this complex set of rules and code into something that's more dynamic and responsive, that can power, the kinds of user interfaces that constituents are used to in our modern era. And it's worth noting that, even when cities move their code online, that's not really what we're talking about in terms of the technology behind the code. This is still essentially a static version of the ordinance. It's getting updated on kind of a normal council schedule, but it's really not yet kind of a dynamic document. So what we've done and what we'll talk about today is we've essentially turned at least parts of this, code base, this corpus of municipal code, into a dynamic schema. And we've used some very modern tools to do that. And we feel like the results of this approach are very, very interesting, just as we all think about, what are we trying to accomplish with zoning code, municipal code? How are fees being calculated? How are permit requirements being expressed and calculated? And how can a more dynamic representation of the code help with all of that? So, this is our agenda for the call. We'll start out with just kind of talking about what the complexity is in planning that we're kind of addressing with technology, and then how technology can help, to try to simplify some of that complexity. And we'll finish with kind of a vision of where we think this trend is going, and, the opportunity for a more responsive regulation. So with that, I'll turn it over to Matt.
Thanks, Joel. Hi, everyone. My name is Matt Gilster. I'm an AICP planner centered in the North Bay. I'm a senior project manager with Open Counter. Over the last 2 years, I've had the opportunity to work with jurisdictions all over the country. And today I'm going to share, I think, my own personal experiences with complexity in planning, both behind the counter, working as a public planner in the North Bay area. I worked across 3 different jurisdictions here in California. And then, my engagement with planning communities across the United States here at Open Counter. So first off, I want everybody to just pat themselves on the back. Being a planner in the modern era is hard. I mean, we have to deal and keep so much information in our heads. And, I was thinking back to when I worked front counter at the jurisdictions I did in California, and I came up with this list of just things that to me were just, they're difficult. I mean, it's hard to keep this information in your head. We have to deal with outdated municipal codes. We have to deal with not clear spatial regulations, overlays, incentive zones, fee schedules that are complex, hard to interpret, and sometimes out of date, development requirements that are not very transparent, hard to find, and, footnotes, variances, all of these standards. I mean, the list goes on. Being a planner in 2020 is hard, and it's just getting more difficult and crazy. And, I experienced this in my work as a planner, working the front counter, even doing long range planning. And I hear this over and over again from the jurisdictions and communities that we work with here at Open Counter. I'm going to give I love showing this slide. So this is a map of the city of Novato. I worked in Novato as a planner for 3 years, and I'm your typical millennial. So I got out of school, I showed up, and they're like, this is how we track our PDs. I say, well, what do you mean? So the city had an intern take a map of the city and draw with a colored pencil in all of the parcels that were part of a PD or a planned development, right? So there's a little labels pointing to each parcel that have a PD. So if someone came into the counter and asked me as a planner, hey, I want to build a shed on my property, what are the development standards? What are the regulations? I would have to go, are you in a PD? They would say they didn't know. So I'd take their address, I'd run back, find their parcel, look at this map, try to find where they were to see if they're inside of a planned development, find the tiny little ordinance reference number that was drawn in, and then find a binder with the printed out development standards that may or may not be there, depending on, whether or not the last planner decided to put the binder back. So, me as a millennial, I came in to look at this and I'm like, wow, this is crazy. There's gotta be a better way to do this. I mean, this is nuts. This is the way that we're tracking this information? Like, and I was frustrated because I had this expectation coming out of college of like, there needs to be a quick fix for this. There needs to be a quick app. Like, this can't be how we track zoning regulations. But the thing is, I mean, at Open Counter, I see this across the United States. We're working with Fort Worth in Texas right now. They have 2,000 of these planned developments, each with their own development standards. DeLand, Florida, we just launched their site. 200 PDs we had to read into our site and deal with. So, I mean, this isn't just my experience. I'm seeing this trending across the United States, is that these zoning regulations are complex. And that's just zoning. So moving on to permitting complications, right? So this is from one of our planning communities. It shows the permit workflow for a stormwater construction ordinance. And they created this as a handout, an informational helping handout to give to the public to guide them through the permitting process. And like, I don't know how many members of the public would find this useful or be able to go through this, let alone myself as a planner. This is so much information. And, if you think about it, this is what you as planners do every day at the counter. You help people through processes just like this. You store all of this information in your head as a planner, which is super impressive. I mean, it's awesome. But at a certain point, how much can you handle? I mean, the longer you work in a jurisdiction, the better you get at handling all this stuff. But when you're dealing with 7 or 8 permit processes that are this complicated, that you're helping people with, there's room for error. And there's also a lot of room for improvement. So all of these things I just discussed, I kind of talk about in the realm of modern planning problems. So, we're no longer doing these like easy, big greenfields developments. You're now required to be a development historian. You have to know all of the history of a parcel that someone's looking to develop. You have to know all of the regulations. You may be dealing with outdated codes or not congruent codes, like codes that clash with each other. And you're also having to deal with very complex regulatory enforcement and permitting flows. This leads to a mental overcapacity that we're seeing amongst planners. And all of this is compounded by evolving user expectations, which I started to see a lot when I was working at a public planning counter, and I'm seeing even more now. Especially with the rise of like COVID-19, users just require more these days. They expect more from us, right? They want online access to all information. Digital only interactions are now required in a lot of jurisdictions. Here in California, all the planning offices that I used to work for are still digital only. And if you've ever tried to guide someone through a complex like permit process on the phone, it's so much more difficult than doing it in person. A lot of times I remember I have people on the phone just come in. It'll be so much easier to explain if you just come in. I can sit you down with the code. It's no longer an option in a lot of places. People want regulation transparency. They want to be able to see the regulations. No one wants to get hit with a $1,000 development impact fee that they didn't know they needed to deal with, right? And I think the biggest thing here is all of the citizens, everybody who comes into a plan counter expects the same increased efficiency that they're seeing in other parts of their life, that they're getting with things like technology, things to help them navigate these complex systems, right? That are difficult to implement in planning. So what does this lead to? It leads to frustrated developers and citizens. And having to deal with that, that's not fun, right? No one wants to deal with a frustrated person at work. And it's just becoming more and more difficult to avoid those interactions. So how do we, take this complexity and fill the gap to meet these modern user expectations? How do we use technology to help us, to use it as a tool, right? So I'm going to pass it off to David to talk a little bit about how this complexity works in technology and what Open Counter has been doing, in that regard. So, all right, David, I'm going to pass it off to you.
Great. Thanks, Matt. So I'm going to be talking about the technological side of this. And unfortunately, when we talk about this complexity, this isn't a complexity that technology can somehow erase. This complexity is innate. It's fundamentally in the regulations. And so that leaves us with really one option, and that's to create tools to help manage this complexity and to help us better understand this complexity. So while we typically see the regulations in text, in big volumes like Joel showed before, this is what our system sees that complexity as. Each of these items is some kind of specification in the regulation that was defined there. And the blue lines, which you can barely tell are lines, are how each element is related to other elements in that regulation. And unfortunately, this video is going to scroll by for the next 2 minutes showing what is involved to kind of correctly make a determination or help an applicant when they come to the counter in one of our cities. So you can see that this is going to fundamentally, there is a lot going on. There's a lot of relations, there's a lot of dependencies, and it's, I would say, almost impossible for someone to put this all in their head. At least I would have said that before joining OpenCounter, just seeing how many items are in play here. And yet, yeah, all of you are in some form or another executing this graph, walking these connections and making these determinations every day you help somebody at the counter. And so what we see in computer science is there are a lot of interconnected items. One of the tools that a computer scientist would reach for in this case is a graph. I'm sure some of you are familiar with this. It's used in mathematics all the time. You probably taught it in high school. And what it lets us do is it lets us show the relations between things. So in this case, we're using our graph is comprised of numbers for the nodes, and the lines in between them show which nodes are connected to their sibling nodes. So this is maybe the example you'd see in a mathematics textbook, but the example that we have kind of every day in life, if you're on social media, is that you are part of a graph. The social media graph is typically users being the nodes, and the lines between them, or in graph terminology, edges between them, are the type of relationship that binds you all together. So again, this is a simple tool. It really only has two elements to it. But this tool for the social graph is capable of fairly accurately modeling the interconnections between everybody in our civilization, or at least the ones that are on the internet and on Facebook or some social media platform. Going a step further, there are multiple billion-dollar industries, all social media companies, that derive probably 80% of their features and kind of value from a graph just like this. If you think about all of the things you can do on Facebook or Twitter or Instagram, any of these things, they're kind of built on top of this core fundamental idea. That is, they understand who you're connected with, who's interesting to you. And these are all problems that can be solved by a computer traversing or moving across this graph and giving us kind of good answers or good data back about how these things interact. The social media examples may be a little bit dated, but graphs are still super relevant, and they are the main contributor that's driving artificial intelligence improvements that we've seen. So, if in the next couple of years, an AI may drive your car. Maybe it's driving your car now, and it would be powered by a graph like this. In this graph, we have, what we're doing is modeling a brain, and each node in this graph would be a neuron in a brain, and each connection would be an electrical connection between nearby neurons, and that would determine if they can communicate or not. So in this case, we are modeling a problem that's even bigger than kind of all the people in humanity. And yet the same simple tools kind of scale nicely to be able to answer questions like this, or to simulate a brain driving a car down the road. And so not all graphs are these spidery looking creations. They don't always kind of map one-to-one to their physical reality. And that's kind of the case of the graph that we care about a lot at OpenCounter, which is the graph that we see inside of every municipal code. And so in this example, or in the OpenCounter graph, it's comprised of 3 main node types. We have questions to the applicant, and those in this diagram are the green circles. We have requirements, licenses, permits. Those are the orange square. And finally, we have their associated fees, which is the blue triangle. And the nodes are interesting, but the really interesting portion of our graph is the associations. And so these associations aren't as simple as maybe a social media graph where you have a relationship type. In our graph, the edges or lines are little discrete blocks of logic. And these discrete blocks of logic aren't kind of created out of thin air. Will have a direct analog to the regulation. So anytime you're reading through a code and there's some condition saying if a permit is required, or if there's any sort of math to determine a fee, those are the things that will become discrete little logic blocks like this in OpenCounter, and they bind everything together. And so this is a very simple example, but let's just kind of go through how this would work. So right off the bat, the system sees, in this example, we have three questions, three theoretical questions that we could ask the applicant. But by traversing the graph, it can determine, as probably most of you have, that the upper left-hand corner question, the will you remove trees, is the most optimal question to ask, because the answer to it will either tell us that we need a permit, or it will shut that permit off. It will say you don't need that permit. And so we can ignore this entire spidery graph underneath it. And so when we have an answer to that question, we can then traverse that line to the tree removal permit itself and say that this is active. We can traverse that line down to its fee. And in a more complicated case, there might be additional conditions here, more rules that say if this particular fee is active and should be calculated or not. In this case, it's always going to be calculated. It's intrinsically linked to the tree removal permit. And so we traverse that down, and the system can see that at this point we have two follow-up questions that need to be satisfied before it could correctly calculate what the fee costs. And so it can surface those to the applicant, and once we have those answers, we can do a very simple mathematics here and figure out that if the answer is true, then we should apply a $10 base rate, and then add that to $40 times the acreage of the property. And so this is a simple example, but it shows that this is a tool that can model these relationships. And once modeled, we can then derive interesting determinations from it. And I'm going to show you the full graph. This is the non-simple version that models an entire city's regulation. And just so you can tell what some of these things are, the yellow or the green circles are the permits, and the diamonds are the fees, and the squares are questions that can be surfaced to the applicant. But what we can see is that while it is, again, a simple tool, it is able to scale up to the level of, tombs of regulation. And it will enforce that each node and requirement is met in a more global way, as opposed to having to remember that each of these things exist. And so that's our graph. And now I'm going to pass it back to Matt to talk about how we use this graph at OpenCounter and what are some of the implications of turning it into this form that a computer can execute and understand.
Thanks, David. All right, so I'm going to give a few examples of, real world examples of how we utilize this graph concept to help planners with their day-to-day jobs. And, I'm going to start with a simple kind of visual so you can kind of follow along, and then I'll show you guys what it looks like, live on OpenCounter's actual website. So this example comes from the city of DeLand in Florida. So Florida, if you guys don't know, it's kind of notorious for having a lot of business tax receipt requirements. So if you're opening a business or doing something in your business, you may be subject to a lot of different types of taxes. So in this scenario, if I'm a planner working at a counter, someone comes in and says, "Hi, I'd like to do a renovation." And I say, "Okay, you require a building permit, please go down the line, go speak to the building guy, he'll get you set up with a permit, everything's gonna be fine." They say, "Okay, that sounds great." They walk away, right? So what happens? A week later, he comes back and says, "Hey, planner, I needed like 5 other permits. I had no idea, why didn't you tell me this? What was going on?" So as a planner, this happens sometimes. And it's because users don't always know what questions to even ask when they're starting a project, right? And when they come to you and just tell you information, you prescribe a solution, but sometimes that's not the actual problem, right? So in this case, with OpenCounter, having all of these instances of what the project can actually be helps us to ask the right questions to the user. So in this case, someone comes in and says, "Okay, I want to do a renovation." And it tells our system, "I want to do a building renovation." "Okay, you'll need a permit." But then the system realizes, well, there's a lot of other permits that could, be required as part of this project. So we need to ask you, what type of project is this? Oh, you're doing a restaurant? Okay. Well, you're also going to need a restaurant business tax receipt. And if you're doing a restaurant, are you going to be serving alcohol? Because there's a lot of requirements around alcohol. The user might not realize all this. It's, oh yeah, I actually am going to be serving alcohol. And, is this a new business? Is this a new restaurant? Oh yes, it is. Okay, well, you're going to need a county tax receipt. You need a city one. And, in this way, this helps us as planners, right? I mean, if a user comes in and doesn't give us the full picture, the full scope, we can't help them, right? If they don't know. This kind of fills in this gap. It prompts the user with questions so they're able to kind of work through their project, right? And you can better prescribe them as a planner. It saves you time. It saves both of you headaches. And, this is great. This is what we're trying to do. We're trying to meet those expectations, right? So I'm going to expand on this example a little bit and show you guys, what OpenCounter looks like on the back end. And, we're going to take this example of remodeling a restaurant. We're going to add one operational change. We're going to, instead of remodeling a restaurant, we're going to be changing a use from a warehouse to an existing restaurant. So changing a use is going to require more requirements. So let's take a look at that. All right, so this is the back end of OpenCounter. So as you can see, I've already inputted the example I just showed you into our system. So this is what the graph looks like on the back end. We have a field here that asks the user, what kind of project is this? Oh, it's a remodel. Okay, that's going to have the requirement of a building permit with a renovation. Below the diamonds, you can see that these are fees that are tied into this building permit right here. And then we also know that if you're doing a remodel, we should know what type of business you're going to be doing. And if you're going to have alcohol. And, is it a brand new business? These all will trigger requirements for the business tax receipt. So you can see in this way, we're able to track this in real time on the back end as users fill out information on the front end of OpenCounter. And so, our users can access this information in order to help them at their day-to-day jobs. But what if, let's do a demonstration of how this can change if a user just does one operational change. Instead of just remodeling an existing restaurant, they're changing use types. So I'm just going to show the front end. This is what the user is inputting. So this is our front end of OpenCounter. In my next example, I'll get into this in a little more detail. But on this page, it's our system asks the user, poses questions to the user. So, it's asking you, what kind of work are you going to do? Oh, you're doing a remodel. Is this a new business? Yes. Are you going to install signs? There's a lot of questions that could go to a specific project that the user might not be aware of. So we're going to change this question to answer this question. Will this business be a different business type than a previous or existing business? So in this case, yes, because we're changing from a warehouse to a restaurant. So let's do yes. Now what we have here is a requirement for a site plan review and site plan infrastructure inspection. So we have two new requirements. So let's go back to our graph, and we can actually see this update now that new requirements are going to be triggered here. So you can see that we have all of our business tax receipts, we have our building permit, but now because of one small operational change, we have a huge amount of complexity that has just been turned on. Now we have a site plan review. Now we have all the requirements involved with that. We have an inspection that needs to be done. We have fees for both of these. So yeah, so this is just an example of how that graph works in real time. So in my next example, I'm going to talk a little bit about fee calculations. So this can also be, and this also ties in with a little bit of that zoning complexity I talked about before. So I'm going to give an example from Omaha. So in the city of Omaha, the downtown area has a development incentive district. So if you're looking to build a house in Omaha, downtown is the place you want to build any residential construction because it's so much less expensive. You don't have to pay development impact fees if you're in a downtown service district. So you can see on one hand, I'm paying a building permit for a new house, $126, it's nothing. However, if I'm outside of the downtown development services district, I'm gonna have to pay $3,000 for my building permit. That's not good. And there's no way to know if you're in one of these districts unless you know what they are, where they are, and and then you can maybe start to calculate some of the fees. So let's take a look at what this looks like on the front end of OpenCounter. So this is Omaha's splash page. I'm gonna click on the residential portal. This is how people scope their projects for, residential projects. So building new houses, additions, things like that. Gives you an overview. First, users are prompted to select their project type, then their primary building type. Then they select a location on a map page. Then we scope the permits and fees required for your project, and then you get a summary at the end. So I'm just gonna go next. I'm gonna select new construction. We're gonna pretend like we're building a new single family home, detached. Now we have a map page. So this is the city of Omaha. And I know that if I build downtown somewhere, if I'm in a development service district somewhere downtown, I'm not gonna have to pay development impact fees. So say a user has a few sites they have picked out. I don't even need to know specifically where that district is. I can click on this map and that information's in the back end of our system. So if I'm in the development services district, I may not have to pay impact fees. And if I don't have to pay impact fees, we'll know. So on this page, this is our permit scoping page. It's gonna ask you relevant questions to trigger permits. I'm gonna just skip through these because we're focusing mainly on the fees here, but we have a building permit that's been triggered for a single family home or a duplex. All right, so you can see our building permit is only $72 and no development impact fees have been triggered. So that means we're probably in that development services district, which is awesome. $82, that's a great deal. So let's see what happens when we change the location of our project. So let's choose something outside of the downtown of Omaha and see what the cost is gonna be to build a single family home. So let's see here. It's a good lot, okay. Let's go to our fees. So now I'm looking at a $6,124 bill, and you can see I've triggered lots of development impact fees. Watershed management fee, community parks fee, and that's before I've even inputted my square footage amounts. So say I'm building a 1,000 square foot home. These numbers might go up or down depending on how big of a house I'm building. But at the end of the day, this is a very, very useful tool for users because they can find this information. They get more information they even know is being presented to them, as a planner. We're taking that complexity that comes in planning and zoning and turning it into something that users can be comfortable with. So this is our summary page. So here we can actually see what zoning districts we're in. This will tell us if we're in the downtown, services area, and will give us a summary of our fees and what we're going to need to deal with. So I'm in a sewer interceptor fee area. That's why this fee is coming up. If we were in the downtown area, the fees wouldn't show up, and it would describe the downtown area, those exemptions. So this is an example of how we can use this kind of graphing on the back end to really make a system that works for users. And I'm going to close out these examples with I'm just going to talk a little bit about these benefits, right? I mean, I was kind of touching on this before, but using technology in this way can make us faster planners. We can be more accurate. We can be more consistent with the information we're giving to people. We can be responsive and interactive. This kind of technology can also span different versions of the code. So like if we have different versions of the site, if things get updated, we can go back and see like what changed. This is an interactive system that could be useful when you're filling that development historian role as a planner. It's context sensitive. Depending on where you are spatially, where your project's located, this, doing a graphing system like this can work. So I'm going to close out my section with a few quotes from some of the planning communities that we work with. So this is from Nicolette. She's the director of Chief Performance Officer in the city of Cincinnati. She says, instead of taking weeks to figure it out, citizens answer 10 to 20 questions and get a customized report in minutes. It's a much better experience for them and much more efficient for the city. So there are these benefits that we can access by thinking about how we can present this information differently to the public. This is just an example of that. Sue Craven, Assistant Planning Director of the City of Omaha, I've been working with for the last months. I love this quote from him. Monumental shift in how quickly people want answers is the driving reason for change. And I see this so much in planning. This has been a big focal point in my career for planning, is that expectations have changed, right? People want things faster. And, we can deliver that to them. If we find and think of better ways to, work with the complexity that we have. All right, so I'm going to pass it over to Joel to talk a little bit about responsive regulation.
Great, thank you, Matt. Get back to my mouse. All right. Yeah, thank you, Matt and David. So, we've gone really deep on, I hope everyone's enjoying this. It's like, we went deep to solve this problem, and we had to get very technical to create a simpler version of the user interface. Matt, do I have, okay, there we go. Sorry, just one second. Right, so if we go back to the municipal code, right, especially in the format, this kind of format, printed format of books, I mean, just think now about, traversing this information to try to get an answer like the examples that Matt was describing, like what's involved in a change of use, what are the fees in one area versus another, all the zoning overlays. I mean, it's really like this kind of format is just not well designed for traversing a lot of different information. I think Michelle noted in the beginning, I started a company a long time ago that was a visualization tool for genetic and drug interactions, and it was a similar kind of problem, right? It's like the physicians have to have this physician's desk reference of like all the different medications, and it's just impossible. It's like beyond what they can remember, and all those things are changing all the time. So, presenting information in the form of a graph, it actually makes it a little bit more intuitive for people if we have to look at the graph, which we sometimes do to, to see what's going on in a project. But, ultimately our goal is to use this way of representing data under the hood to create more intuitive interfaces for citizens and staff. So I just wanted to kind of zoom out at the end of this talk here, and then we'll switch to Q&A, but I just wanted to kind of zoom out and think about, what are the bigger benefits kind of beyond, the open counter software, but what are the bigger benefits of starting to treat the code as something, living and interactive? So let's start with this simple example. This came up for me and early on, after we founded the company. I was doing a demo in Truckee, California, and after the meeting, a planner came up to me and said, I'm so excited about this software, not just to help people get through the permitting process, but like, I want to see who doesn't get through the process. I want to see the people who are, getting prohibited at the zoning step and don't even go further than that, because we don't record that information at the counter. Like that's invisible to me, and I don't really know how many people in the community are trying to do things that are prohibited and what those things are. And we think this is really interesting, because imagine if what this person is trying to do is, Matt's example, like, I want to open a restaurant in the old warehouse district. Maybe the current zoning isn't equipped for that. And this example is actually showing that, right? It's like, and I'm close to an area where it would be allowed, but, in a way, maybe that is a signal to you as planners that like, the community is starting to, entrepreneurs are seeing an opportunity in a new area and thinking in different ways about what's possible in the city. And so we start to show that in some of our analytical tools, what percentage of traffic into the site is, moving forward, what are the use codes, are they prohibited, permitted or conditionally permitted. And to me, coming from more of a software background, this starts to sound a lot like the kind of the typical Silicon Valley playbook of like, you build this software, it's interactive, people are clicking on it, and you get to learn how to optimize those interactions. And maybe it even takes the product to a new level just by seeing what users are doing with it and adapting to those patterns. Another example more towards the graphing side of our system is, what if you could really see in the regulation where people are getting stuck, right? Like maybe you can start to understand that a fee is too high and that people are, seeing that example that Matt gave of the development impact fee and just not moving forward with a project, or getting stuck on maybe even the wording of a question. But a tool like this can help provide data to planners to study those kinds of things and improve the code over time. At a little bit more advanced level, you think about, this is just a screenshot of how we specify the permissions in our system for a single use code across all the zoning districts and overlays in a community. And you can see where we have the base clearance in the left-hand column, and then several footnotes that we found that pertain to certain zoning districts. But these are still, so there's complexity here, but these are still pretty simple kind of like yes, no signals, right? It's like, can I do my restaurant here? No. Can I do it here? Yes. Can I do it here? Maybe. But like, what if we could say, okay, you can do restaurants here, but you can't do 1,000 restaurants here. Like when we get to a certain level of density, maybe we're going to change the regulation, and maybe the regulation could actually do that preemptively. Like maybe we could build the goal into the regulation and frame the regulation so that it adapted and knew what we were trying to achieve. And I'm sure you can all imagine, lots of scenarios where that kind of like responsive regulation could be very interesting. I'm gonna kind of finish off with an example from a different area that I hope is kind of, I don't know, fodder for all of you to think about these things. I mean, I really think this stuff is fascinating, and I just feel like we take so much of this for granted in life. We drive on the highway, we stop at stop signs without even thinking, but these kinds of regulations are, they're there for a reason. They're trying to accomplish something. And, the way that technology is starting to come into these regulations it's very interesting. So, here's something we all see, every day. A speed limit sign, it's made out of aluminum. It's right there when it's snowing, when it's raining, when it's nighttime, when there's a lot of traffic, when there's no traffic. I mean, it's kind of like, it's a regulation that's just static, and it's not adaptive. It's not responding to what's going on, context, etc. We do see some variations on this, things like nighttime speed limits. I think you have those in Colorado. Truck speed limits, etc. But there's still these kind of static implementations of these regulations. Minimum speeds, etc. But what we're starting to see in places, I think this is around Seattle, but the example I found originally was from the M25 highway in England, where basically the highway is covered with sensors, video, radar, weight sensors, etc. So they're constantly monitoring the usage of the highway, the traffic, whether there are accidents, how fast people are driving just kind of on their own. And with that data, that all goes back to a central kind of server center, and they can adjust the speed limits in response to changing conditions on the highway. So, I'm using this example as kind of a simple version of how, we can take these regulations that are kind of currently, they're more fixed, right? 65 miles an hour. And we can start to think about how can technology help us to make those rules more malleable and more flexible and more contextual. So, I think this image is a good one. It's showing, okay, the commuter lane is still 60 miles an hour, but it looks like there's some stop and go traffic ahead. So we're going to slow traffic down going into that, stop and go section, so we avoid, collisions. And, there are charts that the M25 highway system generates that really can show, okay, an accident happened at 7:30 a.m. and it like a stop and go accordion of traffic like rippled upstream up the highway over hours, right? I mean, anyone who drives in congested areas can really feel this, that an accident may have happened 2 hours earlier, but you're still feeling the effects of it upstream. So anyway, I wanted to leave you with this. As planners, you're dealing with, very, very nuanced, complicated issues, the legacy of redlining, how to promote equity in communities. And we certainly have gained a lot of respect for, all that you're trying to achieve and all the kind of history and depth and breadth of these code bases. But, I hope this, talk has kind of triggered some ideas for you of how technology can, create these loops and make things a little bit more responsive, compared with the aluminum speed limit sign or the volumes of code. And that those actually can have a human effect, right? It's not, our goal isn't the technology. Our goal is using the technology to have positive, you know, human impact for people who are using these systems. So I think that's it for me. Michelle, I'll turn it over to you.
Thanks, Joel, David, Matt. That was tremendous. If anyone has questions, feel free to type them in now or raise, I don't think we're doing raised hands, but type your questions in. We did get one question from Robert. If a planner has some familiarity with relational database design, for example, SQL or SQL, and a language such as Python, can she or he customize your applications?
Thanks for the question, Robert. So the answer is no. You might not feel this way right off the bat, but that's actually a feature. So we've designed the system in a way that the same system can be rolled across all of our different tenants. It's always the same system. There's no versions, there's no customizations that happen at the engineering level, so in my world. And we've done that so very on purpose to kind of be an answer to what is kind of the legacy systems that are out there, which is a piece of software that kind of replicates what the human beings were doing before it got there. And it was built, for that city. It will never go anywhere else. So our system has been designed kind of from the ground up. So ideally, you don't need to do that. It doesn't need to be customized. And once the config team goes in and gives it that configuration data that explains the graph, and all of the features can be used by all of the cities. The big benefit of that is that one city is not paying for this entire system in its entirety. They're benefiting from everybody kind of coming together. It also has the advantage of, one day you'll come to the system and the text field will just be a little bit nicer, a little bit more polished. And you and all of the cities that are kind of on our platform would benefit from that.
Thanks, David. Any other follow-up on that one? Okay, and Robert, if that didn't answer your question, feel free to add in some more. And we have another question from Brian. He wants to know, how are some of your current customers using your product to help with COVID changes?
Matt, maybe I'll take a swipe at that and let you follow up, Matt. COVID, this is a unprecedented time. I mean, it really is amazing, and I think what we've learned is, a lot of cities are operating remotely. They're trying to use iPhones and work from home, and honestly, we feel like a lot of cities are doing pretty well. Things are working. I mean, we were on one call with Charlotte, and someone on the call said, I think we'd always wondered if City Hall could operate remotely, and it's like we basically can do it. However, I think what we're seeing is that this notion of a pre-application process, which it's a little bit different than submitting an application, whether paper or PDF or through software, that already assumes that I know what applications I have to fill out, right? So our whole purpose here is helping people see the full scope of their project and what they need to do. I think what a lot of cities are realizing is that they don't have great tools for that. Really the tool for that is the pre-application meeting. It's really, as Matt said, it's so much easier if people can come in and have a 15-minute conversation and just get the big picture from a planner. So some cities are trying to do that with email and phone, but I think that's really what we're seeing, is that the top of the funnel, as we kind of talk about it, there hasn't been a software tool to help with that. And I think cities are having trouble with that. So Matt, anything to add, specific examples?
Yeah, totally. We have seen an uptick in a lot of the jurisdictions that we work with, usage of OpenCounter as software due to COVID. I think it's due to COVID-19. One example that comes to mind is Concord in California. They're one of the planning cities I work with in the Bay Area, and they've seen a big uptick. And, I always say to planners that software like this isn't supposed to, replace a planner. You're never going to replace the front counter experience. And some people need to come in and sit down and talk to a planner. There's just really complex projects that require that human to human interaction. But there is a lot of projects that, if there was another way to kind of, easy things like, where can I build? And, where does the zoning allow this? Things that take up so much of our time as planners that now, are really causing a staff impact. And in Concord, you know, they initially brought us on to help, you know, reduce the amount of tire kickers, easy to answer questions so they can focus on the more complex issues. So I think they did an email campaign to kind of raise even more awareness that this tool existed, and they're seeing a big uptick in usage. And they're not the only ones. There are other jurisdictions that we work with that are seeing, you know, users getting that service that they would otherwise, you know, come to the counter to get, you know, through us, because there's no, you know, that service no longer exists. So, yeah.
Thanks, Matt. Are there other questions from any of our attendees? Something that wasn't covered that you're wondering about? Want to get nerdier on graphing? I know I would like to map all processes this way and then watch a steady stream. And when somebody asks me a question, I just want them to understand how many moving parts are happening at any one time. So I'm looking to see if we have anyone else. Panel, is there anything else that you wanted to leave as final thoughts or wrap up?
I think that's great, Michelle. Thank you. Thanks everyone for your time. Appreciate you attending, and
we'll go ahead and call it a day. All right, everybody, if you have other questions, feel free to follow up with any of our panelists, their contact information. If you don't have it, let me know, and be sure to register those CM credits. Have a great day.
Thanks everyone.